This is Foundations of Math and Pre-Calculus 10, Chapter 9.1. We're going to be looking at solving systems of linear equations by substitutions. And this is a major strategy for solving lots of problems. It also works for non-linear systems. And what we want to do is reduce the number of variables and the number of equations, then substitute the values back to get the whole solution. Some substitutions make it easier, which means we want to minimize fractions. But however we do it, we should always get the same answer. And always substitute with brackets to avoid errors. So let's look at an example. Here we have a y. So really what we want to do is substitute a y. So we change this to 4x, move the y over to the other side, move the 12 over to this side, it becomes minus 12, and the negative y becomes a positive y. This is 1, this is 2. We always number our equations, that way we know what we're doing. Substitute into 1. And we circle it, and that tells us that's an equation. So 2x plus 3, and now we're substituting y. So y equals 4x minus 12, and we put 4x minus 12 in brackets. If you leave out the brackets, then you're going to be doing 3 times 4x, and you're going to make the mistake by not multiplying negative 12 by 3. Now we have one equation and one variable, and that's good. So now we simplify. We have 2x plus 12x minus 36 equals 6. Collect like terms, and we want to collect like terms with variable on one side and constants on the other. 2x plus 12x is 14x. This negative 36 becomes positive 36. So 36 plus 6 is 42. And 42 divided by 14 is 3. Now we need to substitute. And substitute into 1 or 2. Doesn't matter. Whichever one looks easier. And I would say 1 looks easier. So 2 times 3 plus 3 times y equals 6. And 6 plus 3y equals 6. Move the 6 over to the other side, it becomes negative 6. So 3y equals 0, y equals 0. 0 divided by 3 is 0. And you want to write your answer out. Answer. And it's best to write it in coordinate form. 3, 0. X comes first, y comes second. Let's look at doing it a slightly different way. So we can keep the 2x on this side. We move the 3y over to the other side. It becomes 6 minus 3y. Now let's look at equation 2. We can rewrite equation 2. It becomes 2 times 2x minus y equals 12. Okay, so now we have 2x. We substitute the 2x. We don't always have to have just the variable by itself. We can have a coefficient out front. So 2 and 2x is 6 minus 3y. And minus y equals 12. Now we have 12 minus 6y minus y equals 12. So minus 7y, 12 goes to the other side, becomes minus 12. That's 0. So y equals 0. 0 divided by negative 7 is 0. Now we can substitute back into 1. That gives us 2 x equals, and this is now our 1, 6 minus 3 times 0. So 2x equals 6 minus 0 is 6, and x equals 3. 6 divided by 2 is 3. And again, we write our answer out as 3, 0. Let's look at a different problem. Which one's easier to work with? X, because now we can just substitute x. Move the negative 2y over to the other side, it becomes positive 2y minus 13. And we substitute into 1. We're substituting into 1, so we have 4, and we use brackets. 2y minus 13 plus 3y equals 36. We expand this. This becomes 8y minus 52 plus 3y equals 36. 8 plus 3, we have 11y. The negative 52 becomes positive 52, added to 36, and we get 88. So y equals 8. 88 divided by 11 is 8. Now we substitute back into here, and we get x equals 2 times 8 minus 13. So x equals 2 times 8 is 16, minus 13 is 3. And our answer is 3, 8. Okay, let's look at this one. We could do y, but we can also do 3x. If you're uncomfortable with this, work with y. So I'm going to do 3x, and the 2y goes over to the other side, becomes minus 2y, and minus 1. So this is 1, 1. Now we substitute back in, so we get minus, and we just use this whole thing, minus 2y minus 1. There's no need to multiply because this is 3x, this is 3x. All we have to do is put the minus sign there. Plus y equals 13. So we have 2y plus 1 plus y equals 13. 2y plus y is 3y. The positive 1 becomes negative 1. 13 minus 1 is 12. So y equals 12 divided by 3, and that's 4. We substitute it back into here. 3x equals negative 2 times 4 minus 1. 3x equals negative 8 minus 1, that's negative 9. X equals negative 9 divided by 3, that's negative 3. And we write our answer, negative 3 and 4. So this is an enrichment topic, so it's not required. But let's look at how to solve this. We have 3 variables and 3 equations. And if you recall, this system is exactly determined. And what we want to do is get rid of one variable first. So with our first equation, we have x equals, this becomes negative 2y minus 1. And this doesn't buy us anything. We look at this. We can actually look at this as minus 2 times x plus 2y minus 3z equals negative 7. Okay, so if we multiply this by negative 2, we get negative 4y. Multiply this by negative 2, we get negative 2x. So if we substitute something a little bit more complicated, that makes our job easier in the end, because this is equal to negative 1. So we have negative 2 times negative 1 minus 3z equals negative 7. So negative 3z equals Negative 2 times negative 1 is positive 2. Bring it over to the other side, it's negative 2, so this is minus 9. And negative 9 divided by negative 3 is positive 3. Now we can go ahead and substitute. I want to substitute this into 3. So 3x plus y plus 2 times 3 equals 8. And the 3 is coming from z equals 3. We'll simplify this a bit. 3x plus y plus 6 equals 8. 3x plus y equals, this becomes negative 6. 8 minus 6 is 2. Now, from this one, we'll call this 4. We'll do 4. We're substituting 4 into here, so we have 3. Negative 2y minus 1 plus y equals 2. Distribute this, we have negative 6y, negative 3 plus y equals 2. Now we collect our like terms. Negative 6 plus 1, that's negative 5y. Negative 3 over to the other side becomes positive 3. 2 plus 3 is 5. 5 divided by negative 5 is negative 1. Now we plug it all the way back into 1. Actually, we can just plug it into 4. And we get x equals negative 2 times negative 1 minus 1. So this is positive 2 minus 1. X is equal to 1. So our answer is 1, and y is negative 1, and z is 3. And that completes this lesson.